Previous video, we learned about the theory of ideal gases, and we learned that there's an equation which can describe the behavior of ideal gases, and it goes like this. Get the pen working. Here we go, PV equals to N or T. Quick reminder what each of these symbols stands for. P is equal to pressure. And pressure has to be measured in SI units. That's very important for this equation, so pascals. V equals volume, and again, this must be measured in SI units, which are the meters cubed. N is equal to the number of moles. That's obviously in moles, or is what we call a universal gas constant. Universal gas constant, and because it's a constant, it always has the same value. It's 8.31, and it's joules per mole per Kelvin. But we're not worried too much about that unit. Just know that this will always be given to you on your exam paper. It's usually on the front page. And T was the temperature of the gas. And again, it has to be measured in SI units, so it needs to be Kelvin. So when we approach problems involving this equation, it's very important that the first thing we've got to check is we've got to check what units is each thing given to us in and ensure that we do our conversions to SI units before we begin. So if you're not familiar with this and you haven't seen this before, it's probably a good idea to go ahead and take this down. It's called the it's called ideal gas equation. Ideal gas equation. Now, for different problems here, we're going to have to rearrange this formula and make different elements of it the subject. So I showed you how to make things the subject of an equation before. It means that you have to get that thing on its own on one side of the equation and move around the other stuff. All right, so you guys should know how to do this already. For these first set of problems that we're going to practice in today's video, we need V to be the subject of the equation. So I'm going to get you guys to go ahead, pause the video, try and first of all write this down and then try and manipulate it to make V the subject. Pause the video and do that now, because you should only be playing if you've really had a go at making V the subject here. All right, so let's write down what we have. I'm just going to rewrite it down here. PV equals N or T. Now currently we want V to be the subject, and currently V has been multiplied by P. So this here is the same as saying P times V. So P with V written after it, P multiplied by V. Now both of these are currently in a numerator. They're not being divided by anything, they're not in a denominator. And I showed you before that if you want to get rid of something in the numerator, you've got to make a denominator with that same thing in it. So in orange here, what we're going to do is we are going to put a denominator and we're going to put P in the denominator. What I can then do is cancel out the P's, because P over P gives you 1, and now you just got 1 times V, which is V. Good. And this here is equals, which means if you do something on the left, you have to make the same change on the right. So I'm going to make a denominator here and put P in the denominator. I'm going to go ahead and rewrite it now without the cancel out stuff. I just have V equals to N or T over P. So this is the version of the equation we're going to need if it asks us to calculate a volume. All right, so we're going to jump over here now and we're going to look at some practice problems. So this one here. You'll see that it says find the volume occupied by 0.05 moles of carbon dioxide, CO2, at 298 Kelvin and a pressure of 100 pascals. All right, so the first thing I'm going to do is I'm going to write down my data. So what information do I have from the equation? So I'm going to get you guys to pause the video in 1 second. We're going to underline the bits of data that are important and get you guys to make a list here where it says D. You're going to make a list of the different things that we know already. Okay, so where I put the dots there, that's where you're going to put that information. And it's always a great practice to get into. That's what I'm writing D here for, stands for data. You don't have to write the D, but somewhere before you begin at the top of your question, you should always write down what you know from the question. So I'm going to underline that stuff and let you write it down. So first of all, something that might be important is this. Okay, write down that stuff first of all. Go ahead, pause the video, write it down. All right, so what I would do here is I would say, okay, 0.05 moles, this is N from the equation. So I'm going to go ahead and write down N, number of moles, equals 0.05 moles. That's the first thing I'm going to write down. This here is obviously 298K, which is a temperature, and it's already in Kelvin, so that's good. Temp, or I'm actually going to shorten that to just T. So T, capital T, equals 298 Kelvin. The next thing is, here is a pressure in kilopascals. So P equals, now it says 100 kilopascals. So in rough work, I'm going to go ahead and I'm going to convert that 100 kPas times by, for there are how many pascals for every kilopascal. So cancel out my units and leave me with PA. You guys should know what I'm doing here. This should seem familiar. This is simply converting units. And what I know is my conversion factor here is that there are 1,000. Sorry, what's going on here? Yeah, there are 1,000 pascals for every 1 kilopascal. That's going to give me 100,000 pascals. So that's what I'm going to put up here, 100,000. And it has to be pascals you put in this equation. That's very important. All right, so I'm missing some things. I'm missing or and I'm missing T. Now, I told you or will always be given to you, so I'm going to tell you what it is. Or is equal to 8.31. Always be on the front of your exam paper. What else am I missing then? P, V equals N or T. So I'm missing V, and that's good because that's what I was asked to find. That's my question mark. I've got my other 4 variables to plug in and leave myself with V. Right, in the next box here, we're going to go ahead and we're going to write down what version of the equation do I need. So this is the one that we just rearranged over there. You should have that somewhere. Pause the video and write this in here. Okay, now again, you don't have to have E. I just like to have this thing here as a way of knowing how to lay out my question. What this means is equation, and what we just worked out is that V equals N or T over P. Okay. All right, so on the next line now, what we're going to do is we're going to take these numbers and we're going to put them in instead of the letters or instead of the symbols. So this is called substituting in. So again, if you guys know what substitution means, if you used this in formulas before, go ahead, pause the video and sub in the values on this next line here. So you're going to get V equals and you're going to sub in the values. Pause the video, do that now. Okay, so what you would do here is you would say, okay, I've got 0.05 moles, so I'm going to put that in on the top line. On the numerator, I'm also putting in or, which we said was always 8.31. So I'm going to put that in here, 8.31. I'm putting in my temperature in Kelvin, 298. Ooh, that's a mistake. 298. Good. And then in the denominator, I need P. And P, we said, was 100,000. All right, so C, next line just means calculate. So you get out your calculator, put this in exactly the way you've written it down. Notice I've not gone to the calculator at all until I'm confident I've got it right on paper. That's always the best strategy to follow. Okay, so what I'm getting here is the volume is equal to 1.238. I'm going to stop there. There's 2 more numbers. I'm going to stop there. Times 10 to the power of minus 3. And my answer is always in SI units, so meters cubed. Okay. This U usually means this is the line where I put the unit in. So you could just leave the number there, sorry, and you could do that down here. So V equals 1.238 times 10 to the minus 3 meters cubed. And this U here just reminds you to always make sure you include the unit, because sometimes you usually don't get the full marks unless you've included the unit. All right, so that's the process of how to use, how to rearrange this ideal gas equation and go ahead and do a problem with it. You're going to do this one for me now. So you're going to do this one and get you started. All right, let's help you underline what we know in the question. What's going to be important here? This is going to be important. This is going to be important. And this is going to be important. But be careful with this and be careful with this. So go ahead, pause the video, and first of all, before you go any further, just fill in the data. What do we know from the question? Let's make a list of the things that we know. Pause the video, do that now. All right, what you should have written is that N is equal to 16 moles. you should have written that T is equal to, okay, so 0 plus 273 gives you 273 Kelvin. So that's how you convert to Kelvin. You add 273. And now that's what goes into your answer. And we've got 100,000, we've got 100 kilopascals. Now I'm going to cheat and take out that from the last one. That is P equals 100,000. We've already done that once, not much more point in doing it again. We also know R is always 8.31, and V is what we're trying to find again, because it says, look, find the volume. Okay, so go ahead, write down the version of the equation we need. Should have done this, V equals N or T over P. On the next line, sub in the values. Just pause the video and do that now. And then go ahead and finish it off. So you should be able to get to the end now by yourself. Okay, so you should only be playing if you've had a go at this. Quickly walk you through it. V equals 16 times by, we've got 8.31 times by 273 Kelvin. All that is over 100,000. Probably going to get a very similar answer to the last time. 16 times 8.31 times 273. Divide that by 100,000. Just make sure you got the right amount of zeros. Yep. Getting 0.36298. So I'm actually going to round it to 3 decimal places. 0.363. And on the next line, 0.363 units are meters cubed. I'm just going to go back and check that previous one. Oh no, that makes sense because the moles was a lot lower here than it was here. So that makes sense. Okay, I thought they'd be closer than that, but yeah. All right, guys, so that is the first two. You should be confident about doing the next one now. I'm going to get you to pause the video and have a go at 168 and 169. Okay, we're going to check those out the next day in class. What we're going to do now is we're going to just see a rearrangement in a different way of this equation. So let's look at the next example. In this case, look what it says. What is the pressure? So in this case, we're being asked to find P. So P is the unknown in this case. What is the pressure is what it's asking us. So that's the first thing I can write down here. P equals question mark. That's what I want to find. All right. Now you go ahead, pause the video and write down the rest of the data we know. Okay, so the rest of the data we know, we've got 16 degrees C, okay, which isn't in Kelvin. So I'm going to go ahead and convert to Kelvin. You do the same if you haven't already. If you missed that you have to do it. Okay, what you should have done is temperature equals 289 Kelvin. And we've got a 3.25 decimeter cubed container. Okay, so that's a little bit tricky. Let's do that one together. 3.25 decimeters cubed, dm cubed, times by. Okay, so decimeters cubed is to centimeters cubed. There are 1,000 centimeters cubed in 1 decimeter cubed. So that converts it to centimeters cubed for me. And then from there are, cancel my centimeters cubed, there are 1 by 10 to the 6 centimeters cubed in 1 meter cubed. All right, so we must have our answer in SI, we must have our unit volume in SI units. So 3.25 times by 1,000 over 1 times by 1 over 10 to the 6. 1 over 1 by 10 to the 6, sorry, 1 by 10 to the 6. To the 6 equals. All right, so we're going to get 3.25 times 10 to the minus 3. Okay, that is meters cubed. So I'm going to go back here. I'm going to fill that in. V equals 3.25 by 10 to the minus 3. Right, I know R is always the same. R is always 8.31, so that one's fine. And then N is a problem here again because I've got grams and I need moles. So again, I have another conversion to do, rough work, before I begin. What is it? 0.842 grams of H2. 0.8, sorry, 0.842 grams of H2 times by, right, I'm going between grams of H2 and mole of H2. All right, so first of all, for every 1 mole, how many grams is there? Well, there's 2 atoms of hydrogen. Each atom is 1, so it's 1 times 2 is the mass, or just 2. So I'm going to get 0.842 times 1 over 2. Equals 0.421 moles. So quite a lot of messing around and conversion here. All right, the next thing we've got to do is rearrange the equation so that it has P as the subject. So pause the video and have a go at this now. All right, so obviously we have PV equals to N or T. We want to remove V from the left-hand side. So we make a denominator with V in it, and that will cancel out the V's. Make a denominator with V on the other side. Very straightforward. P equals N, N or T over V. All right, pause the video, go ahead and finish the rest of it. All right, so subbing in your numbers here, you should have got, I'm just going to give you the answer now, 0.421, but 8.31 times by 289. Okay, so this is the number I'm getting as my answer, 311,098.274, and that would ultimately be pascals for pressure. So quite a high pressure, 311,098.274 pascals. All right, so that is that example. So what we are going to do now is you guys are going to do this one here. Pause the video and have a go at it. And you're going to try 170 as well. All right, so again, we'll go through the answers to them in class the next day. All right, the last thing we're going to look at is what happens, how do we rearrange it to get the number of moles N? Okay, so in this question, look what it's been asking for. Calculate the number of moles of the gas. So N is the unknown. And this is the most common way that it gets asked in the exams. So N equals question mark. That's where we will see this. So what I'm most concerned about is I'm confident that you guys can convert these things now. But what I'm most interested in figuring out here is the equation. So what we're going to do is going to get you to pause the video and write down the equation which has N as the subject. Pause the video and do that now. Okay, so first of all, you start with the original one, PV equals N or T. We want N to be the subject. Now N is currently being multiplied by R and it's also being multiplied by T. So we want to remove them from the right hand side. They're currently in the numerator, so we're going to make a denominator. And we're going to put R and T in the denominator, and they will cancel with that R and T to give 1 and 1. So N times 1 is N, times 1 is N. So we just have N on the right. And because we made that change on the right, we also going to make that same change on the left, R T. So that gives me N equals to PV divided by R T. All right, so once you know that, then you're you can pretty well find N in any case. So pause the video and find N in this case, and then pause the video and find N in 171 and in 172. All right, we're going to go through the answers to all of them in class the next day, guys. If you're in my class, if not, then sorry, but the video gets too long if I go through every single one. I'm sure you have a good idea if you're doing these right or not. So that's it, guys. I'll see you in the next video. That is the ideal gas equation. It comes up as part of this experiment. It's usually the final calculation if you get asked about this experiment to determine the relative molecular mass of a volatile liquid. So we will be finding N in this experiment. We'll discuss that a little bit more when we do that experiment. All right, guys, that's it. I will see you in the next video.